course on Calculus for Business Part 2 Integration. As I said, we are going to talk about the concept of integration in this course. Okay, as an introductory lecture, in this I am going to tell you something about integration. This is generally known as the inverse process of differentiation. So, are we going to discuss any applications or where it is used? Yes, of course, but that is already spoken in our channel, and the link to it is given in the description. You may refer to that video, and you can see these are all the places where integration is used. So, in this lecture, what are we going to do? We will see the mathematical aspects of integration, and we'll start with the concept of indefinite integrals. Okay, as it is said, it is inverse process of differentiation. Okay, so consider d upon dx of x power n is n times of x power n minus 1. This we know for sure. So when you integrate n into x power n minus 1, you will have to get x power n. Right? So this is actually taking place. So till now I have not given you I have told you in the concept of differentiation that d upon dx means what is the change happening to some function y or x power n whenever there is a change happening in n. So here integration, it is the symbol to integration is this. This is the extended version of like what sum. So integration basically means it is the process of taking infinite sum, and from the alphabet, yes, this integration symbol is invented, and it was invented by a mathematician called Leibniz, right? So in wordings I have written integrate n x power n minus 1 is x power n, that is integral n power. So this is with respect to x, that is important here, is x power n. Whether you differentiate x power n or x power n plus some constant k, whatever may be the thing that you differentiate, you are going to get n into x power n minus 1. So, when you integrate this n into x power n minus 1, you will have a constant c. Right? This has to be noted clearly. Now, just for the purpose of simplicity, let me take some y to be n into x power n minus 1, and let me rewrite my dx as dy. Okay, I am just making these changes. When I do so, what would be my sorry, I think it would be better for me. Okay, if I write simply y power n dy, what is going to happen? So when I had x power n minus 1, okay, I'm not making any substitutions. I'm just going to compare things and give you the formula for integration, right? In the place of x power n minus 1, I have y power n. So one power is whatever may be the power that you have here, one power has to be increased here. Okay, then now if you have with n is multiplied here and the n is not here, which means this n is divided by that n. So whatever is there in the power is to be divided. So which means here you are going to have n plus 1 plus c. So this is the actual formula for the integration, right? And when you write, okay, in general, we may integrate any function. So in general, if you write integral f of x dx, here x is called the variable of integration, right? When you integrate your f of x plus f of x dx, you are going to get some function of x along with c. Here your function small f of x is called the integrand. So this is the function to which we apply the process of integration. And big F of x is called the integral or antiderivative or primitive, primitive or particular integral of f of x, small f of x, and the c is called as constant of integration. The process of finding integral is called as integration. Now let me give you a few standard formulas. The first one that we have seen, and this is true only for n not equals 1, which means whether you take any n value, but that n must not be equal to minus 1. For all those cases, this formula is valid. And what is happening with x power n when n is minus 1? So in that case, it becomes 1 upon x. So when you integrate 1 upon x, you are going to get log x. And integral e power x is e power x itself. And these are some other standard forms which we will make use of. Right? So the process of, okay, I have said something about indefinite integrals. Right? Let me write here. So that is the idea that we are going to see in the rest of this lecture. Indefinite integrals means these standard forms are of indefinite integrals, because you are not sure of from where to where you are integrating. I told you people that integration is the process of taking infinite sum, right? So when you are making an addition process, summing process, you have to be aware of from where to where we are adding. What are the things that we should add? If you are aware of these things, then that is categorized as definite integral. Here, when you are not aware of these things, then it is categorized as indefinite integrals. In general, integral f of x dx, integrals of this form are indefinite integrals, and definite integrals are of the form integral a to b f of x dx. What is this a and what is this b? These are known as limits of the integration, and these details we will discuss in the next lecture. Now we will get into this lecture. So we will work out few problems. So the first problem is evaluate integral x power half dx. Right? As the solution suggests. Okay, whatever may be the formula that we require to complete this problem, let me write here. Integral x power n dx is x power n plus 1 upon n plus 1 plus c. Okay, when you differentiate, you had something which is to be multiplied with the function and the power is reduced by 1. When you do the integration, the power has to be increased by 1 and the quantity has to be divided. Okay, so just everything is in a reverse manner. Okay, using this formula, okay, we know that integral x power n dx is x power n plus 1 upon n plus 1 plus c. Here n is what? Half. So integral x power half dx is x power half plus 1 upon half plus 1 plus some c. What is half plus 1? It is x power 3 by 2 upon 3 by 2. So this 2 is in the denominator of the denominator, hence you may take it to the numerator. So it is 2x power 3 upon 2 by 3 plus c. Right? The next problem is we are asked to evaluate integral 2 power x plus 4 upon x minus a upon x power 1 by 3 dx. So here, what are the formulas that we are going to make use of? Let us revisit and check here. If you see, we have 2 power x, so which means this fourth formula we'll have to make use of. And the fifth one, if you multiply some constant to a function, you can take the constant outside and do the integration process. That one we will make use of. And the sixth one, if you have a sum of two or more functions or a difference of two or more functions, that can be split. These are the things that we will make use of. So we know that integral a power x dx is a power x upon log a to the base e plus some constant c, and integral 1 upon x dx is log x plus c, and integral x power, okay, let me write it in the next line itself. Integral x power n dx is x power n plus 1 upon n plus 1 plus c, and constant times of f of x dx is constant times of integral f of x dx, and integral of f1 of x plus or minus f2 of x dx is integral f1 of x dx plus or minus integral f2 of x dx. Okay, these are the things that we will make use here. So first, initially, integral 2 power x plus 4 upon x minus a upon x power 1 by 3 dx. This may be written as integral 2 power x dx plus integral 4 upon x dx plus minus of a upon x power 1 by 3 dx. Now we shall take the constants outside, so it is 4 times of integral 1 upon x dx, and here the constant is minus a, and 1 upon x power 1 by 3 dx, right? When you do the integration to the first term, you are going to get 2 power x upon log 2 with base e, then 4 times of log x with base e, and minus a times of 1 upon x power 3. So this may be written as x power minus 1 upon 3 dx. Okay, the first two terms remain the same as we have done the process of calculating the integral values, and this is x power minus 1 by 3 plus 1 upon minus 1 by 3 plus 1. So the first two terms are there as it is, and minus a upon minus 1 by 3 plus 1, which is minus 1 plus 3 upon 3, which happens to be 2 upon 3. Fine. So with which we do the rest of the problem. It is x power 2 by 3 upon 2 by 3, and if you want, you can take the denominator of the denominator to the numerator, and hence the answer is minus 3a x power 2 upon 3 upon 2, and this completes this problem. Okay, and here we missed something, right? So we have forgot to add the constant of integration c. When you split these things into three different integrals, you may ask me that is it necessary to add the constant of integration for each integral? It is not so. If you add only once, it is enough, right? You are not very sure of what constant that is. In the first integral, you may get some constant. In the second integral, you may get some other constant. In the third integral, you may get some other constant. But finally, when you add these three constants, you are going to end up with some other constant. So, still now we are not aware of what constant that is. right? That C is just to denote we are going to have some constant here, but we are uncertain of what constant that is. So it is enough to add only once. Let us go to the next problem. Integral x plus 1 upon x whole square dx, right? So let us start the solution. If you see, your x plus 1 upon x whole square dx shall be written as, using a plus b whole square formula, x squared plus 2ab plus b squared. So it shall be written as integral x squared dx plus integral 2 x and x gets cancelled to, so 2 dx plus integral 1 upon x square dx. And from the first one, okay, let me write things as it is. Plus this shall be written as x power minus 2 dx. Okay, so this would give you x cube upon 3. So x power 2 plus 1 upon 2 plus 1. Plus 2 is a constant, so you take it outside, and when you integrate dx, you are going to get x. And this is x power minus 1 upon minus 1 plus constant of integration c. So the final answer is x cube upon 3 plus 2x minus 1 upon x plus c, right? The next problem that we are going to see is integrate e power x minus 1. Okay, let me write the complete problem. Integrate e power x minus 1 with respect to x. It may be given in this way also. So we'll have to do integral e power x minus 1 dx. This shall be written as integral e power x dx minus 1 times of dx. So it is e power x minus x plus some constant of integration c, right? And the next problem is integrate x cube minus x plus 4 upon x squared with respect to x. So we are asked to actually find integral x cube minus x plus 4 upon x squared dx. This shall be written as integral x cube upon x squared minus x upon x squared plus 4 upon x squared dx, and this is integral x dx minus integral 1 upon x dx plus integral 4 upon x squared. This may be written as x power minus 2 dx. So this is x square upon 2, and this is log x to the base e, and once you take 4 outside, you will have minus x power minus 1. So actually you would have x power minus 1 upon minus 1. So this is x squared upon 2 minus log x to the base e minus 4 upon x, and this completes the problem. And actually we forgot to do one thing, that is by add, that is we'll have to add the constant of integration, and this actually completes the problem. Thank you.